Hello everyone, this is Matthew Craig. In this video I'm going to discuss binary, its relationship to decimal, and also go through the process of converting numbers between binary and decimal. First of all, what is decimal? In mathematical jargon, it is a base 10 positional numeral system. It is the most widely used system by modern civilizations, as you could guess. It has digits from 0 to 9, hence why it is called base 10. So let's compare that to binary. Like decimal, binary is a positional numeral system, but instead of base 10, it is only base 2, and uses the digits 0 and 1. This is the system used by computers to represent information. There are other systems as well, which are used for various things by various people, but don't worry about those. Converting between binary and decimal, or any other numeral system, is something that all computers do constantly. Whenever they receive input from keyboards, displaying information on a monitor, etc., the computers make these conversions. So how can it be done by hand? Well, the secret to doing it easily is to use the place values, something that any elementary school student has learned. For any whole number in decimal, you have the ones place, tens, hundreds, etc. Every place value is a multiple of 10, and they can be expressed as powers of 10 as well. So, for example, take the number 34, which happens to be 30 more than the day of my birth, which is 4th of September. 34 is 3 tens plus 4 ones. So, how do we put that in binary? Just like the decimal system, binary also has place values, except instead of multiples of 10, these are multiples of 2. Because it's a base 2 system. The place values are 1, 2, 4, 8, 16, 32, etc. These can also be represented by powers of 2, just like the decimal system. If we want to convert 34 into binary, you first find the greatest binary place value that is less than that, and then you subtract it. Meaning that in binary there is a 1 in the 32nd place value, or the 2 to the 5th power place value. The remainder between 32 and 34 is 2, which is the 2 to the 1st power place, the second place. So you put a 1 there as well, and you fill in all the other spots with zeros, and you get the binary equivalent of 34, which is 1,00010. This same technique can be used for converting into hexadecimal, octal, decimal, any other positional numeral system. So now that we've accomplished that, let's go the opposite direction and take a binary number and convert it into a decimal number. Converting into decimal is actually much easier than converting into binary. This number here, 1010101, will work as a fine example. So, lay it out, decide what the place values for each digit are. Now, just multiply the place value by the digit and add them all together, and you'll get the number in decimal. So you've got 1 times 64 plus 0 times 32 plus 1 times 16 plus 0 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1, and after adding all these together you get the 85, which is the binary number 1010101 in decimal. This same method can be used to convert into decimal from any other system as well. Okay, so I hope you've learned a bit and can now successfully convert between binary and decimal. If you have any questions about this topic or anything else, feel free to leave a comment below and I'll be happy to answer any questions you have. So, as always, this has been Matthew Craig, and thanks for watching.